Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. Series of Pythagoras questions. 22 is in the first quadrant, so you have no choice of where to draw your right. So we're going to go and draw a Pythagoras diagram in the first quadrant. Right, so our 22 degrees goes in here, and drop your perpendicular to give you your Pythagoras, and cos is x on r, or adjacent on hypotenuse, so this will be p, this will be 1, and if you do Pythagoras, you will get p squared plus y squared equals 1 squared. So y squared equals 1 minus p squared. Y equals the square root of 1 minus p squared. And I normally make my pupils write stop because everybody thinks that they can carry on another step and square root that, which you can't do. Right, so we're going to go and put that label up here for the y, and that is 1 minus p squared. Right, first question is cos of 562. Right, cos of 500, sorry, that doesn't look like a 562 degrees. Right, I would subtract a revolution from that and you will end up at 202 degrees. And then cos of 202 is cos in the third quadrant. So you use the third quadrant formula and you will get 22. Then cos in the third quadrant picks up a negative. And we are now down to our acute angle. And cos of 22 is adjacent on hypotenuse, which is p, and carry the negative down. And that's it. Nice and easy. Next question. B is cos squared of negative 158. Right, first thing is to add a revolution to the negative 158, which gives you 202. So we are left with cos squared. Using your cos diagram, that is 180 plus 22 degrees. Now be careful. Cos in the third will pick up a negative, but with the square, it will then become positive. Keep the cos squared of 22, and that will give us cos squared of 22 is going to be p squared. Right, so let's pick up a color. Lots of catches. First of all, add a revolution. There's nothing difficult in that. Next is 180 plus is third quadrant, but a square has to be positive. Keep the square, and your answer is then cos squared of 22 is p squared. Right, next one is sine of 248, which is in the circle, so I'm just going to reduce it using my cast diagram. That's going to be 180 plus 68. Right, now we're going to say that is sine in the third, which picks up a negative, sine of 68. And then I'm going to use a cofunction. Keep the negative. Sine changes to cos of 22 degrees. And that gives me negative p. Right, so there's cofunctions coming in. Nothing difficult about that one. And the last one, tan squared of 202 is tan squared, reduce 202, it is 180 plus 22, which is in the third quadrant. And so it would be positive, but with the square it remains positive. So it's tan squared of 22. And carrying that on over here, tan squared of 22 is squaring. Tan is opposite over adjacent, so it would be the square root of 1 minus p squared, all on p, all squared, which then gives us 1 minus p squared, all on p squared. And that's it. Let's just go back, pick up that we have a square, that it will always be positive, and reduce before you do anything else. Right, let's take our 5 sine theta minus 4 equals 0, and we will get sine of theta is 4 on 5, and sine is y on r. And then to know which quadrant we use, because sine can be positive in first and second quadrants, we need to have a look at complementary. Complementary angles means theta plus beta add up to 90 degrees, and the only way two angles that we always assume are positive unless we are told differently can add up to 90 is if we are in the first quadrant. So we're going to go right, so we are going to be labeling from the numbers that were given for theta. So I would put theta into standard position. Okay, that's over here. I would close off my right angled triangle, and sine is y on r, so it is 4 here, 5 there, and if we do Pythagoras, it's a 3, 4, 5 triangle. The r is 5, so 3 on the x-axis over there. Right, now important, going back to these complementary angles. I've labeled my diagram with the theta because that's where my numbers came from. So I've labeled it, but if this is a 90-degree angle here, then this has to be beta here because of some angles of a triangle. So what you have to watch out for very carefully is, if you are doing theta in the question, then your opposite is 4 and your adjacent is 3. But if you are working with beta, your opposite is 3 and your adjacent is 4, because beta is not in standard position. Right, so let's go and put in those fractions. Right, so cos of theta is opposite over adjacent over hypotenuse, so that will be 3 on 5 minus cos of beta is adjacent over hypotenuse, which is 4 on 5. Right, and then in the denominator, cos of beta is adjacent over hypotenuse, so that is 4 on 5, times by sine of theta. Sine of theta is opposite over hypotenuse, so that's 4 on 5, and that is going to give me 8 on 15 in the numerator using an LCD, and on 16 on 25, and final answer is going to be 5 on 6. So that is an unusual one. I just want to draw in a line here. It's not going to be very straight. Here we go. And that's number 4. This example is of an DEB paper, November 2015. It's got an unusual question at the end. Right, so they've given us x and 24. They've given us that line there is 25. That is beta. And they want us to find the value of x. So we're going to do Pythagoras. X squared plus y squared equals r squared. And that is Pythagoras. I'm just going to do Pythag because I'm running out of space. So it's going to be x squared equals 25 squared minus 24 squared, and on your calculator you will get that x is plus minus 7. It will be negative 7. Right, then on to the next question, which is B, and that is find, let's just do one of them, tan of negative B. Right, my favorite negative. B, a negative is in the fourth quadrant. Negative is in the fourth quadrant, where tan would pick up a negative. So that gives us negative tan of B, and that will give us negative tan is, remember this is now minus 7, it's going to be 24 on negative 7. 24 on negative 7. And the next question, I'm really trying to squeeze this one in. It is such an important question. C is going to be sine of beta. So sine of beta is just going to be opposite, which is y, on your hypotenuse. So it's going to be 24 on 25. Right, and now for the interesting ending. I'm sorry I'm having to squash it into the corner here. It says if O to T is now 15, then they want us to find the coordinates of T. Right, so I'm going to drop down a perpendicular, and I'm going to call that X, and I'm going to call that Y, and I'm now going to start again using those values. So I'm going to write, first of all, X on 15, what I'm looking for over what I know is the cos of B, and the cos of B is going to be X on 15 equals cos of b, which is negative 7 on 25. Right, so take the 15 up, use your calculator, and you will get x is equal to negative 4, 2. And I'll just change colors so that you can see. To find y, we're going to say y on 15 is going to be sine of b. So y is going to be 15. Sine of b, we worked out here, was 24 on 25. So y is equal to 14,4. And then squashed in the corner here, t is going to be negative 4, 2 and 14,4. Very unusual question. Very surprised to see it on a grade 10 question paper. I think that grade 11s would also find it quite a challenge. So I'm really sorry that the best part of that question is stuck in the corner, but it's all done with the ratios, and I hope you understand it. And I have finished 5 of the 6 questions, but the most important one for me was number 5. So hope you enjoyed it, hope you've learned something, and hope to see you at the next lesson. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos, and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.